Average velocity and average speed. Average velocity is defined as the change in position or displacement delta x divided by the time intervals delta t in which the displacement occurs. V bar is equal to x2 minus x1 upon t2 minus t1 is equal to delta x upon delta t, where x2 and x1 are the positions of the object at time t2 and t1 respectively. The SI unit for velocity is meter per second. Like displacement, average velocity is also a vector quantity. Consider the motion of the car as shown here. As seen from the plot, the average velocity of the car between time t is equal to 5s and t is equal to 7s is V bar is equal to x2 minus x1 upon t2 minus t1 is equal to delta x upon delta t is equal to 27.4 minus 10 upon 7 minus 5 is equal to 17.4 upon 2, 8.7 meter per second. Geometrically, this is the slope of the straight line P1, P2 connecting the initial position P1 to the final position P2. The average velocity can be positive or negative depending upon the sign of the displacement. It is 0 if the displacement is 0. Here you can see an xt graph for an object moving with positive velocity. Moving with negative velocity. Average velocity, as defined earlier, involves only the displacement of the object. But the magnitude of displacement may be different from the actual path length. To describe the rate of motion over the actual path, we introduce another quantity called average speed. Average speed is defined as the total path length travelled divided by the total time interval during which the motion has taken place. Average speed is equal to total path length upon total time interval. But it does not tell us in what direction an object is moving. Thus, it is always positive in contrast to the average velocity, which can be positive or negative. Look at an example. A car is moving along a straight line, say OP. It moves from O to P in 18s and returns from P to Q in 6.0s. What are the average velocity and average speed of the car in going from O to P and from O to P and back to Q? First case, from O to P. Average velocity is equal to displacement upon time interval. V bar is equal to 360 meters upon 18s is equal to 20 meter per second. Average velocity is equal to 20 meter per second. Average speed is equal to path length upon time interval is equal to 360 meters upon 18s is equal to 20 meter per second. Average speed is equal to 20 meter per second. Thus, in this case, the average speed is equal to the magnitude of the average velocity. Second case, from O to P and back to Q. In this case, average velocity is equal to displacement upon time interval is equal to OP minus PQ upon T is equal to plus 240 meters upon 18 plus 6s is equal to 1.0 meter per second. Average velocity is equal to 1.0 meter per second. Average speed is equal to path length upon time interval is equal to OP plus PQ upon T is equal to 360 plus 120 meter per 24 second is equal to 20 meter per second. Average speed is equal to 20 meter per second. Thus, in this case, the average speed is not equal to the magnitude of the average velocity. This happens because the motion here involves change in direction so that the path length is greater than the magnitude of displacement. This shows that speed is in general greater than the magnitude of the velocity.